So we're going to jump right into this. I'm excited to tell you a little bit about our technology. Excited to tell you a little bit about lessons that I've learned trying to build a space company alongside my amazing team and all the amazing people outside our team in Canada. In addition, I'm really looking forward to telling you what our plans are for the next couple of years to bring space closer to Canada. So let's jump right into it. Obviously, Canada has a very rich history in space. I think it was mentioned earlier today that acknowledging, I think Alex McDonald really mentioned it, acknowledging our past and how much we've accomplished in space as Canadians is incredibly important. We have some incredible artifacts at the back there, from the Canada Arm to Alouette 1. We're the third nation to have a satellite in orbit. Obviously not launched by Canadians, unfortunately. We had the Black Brant, incredible sounding rocket program, but we've never launched to space before. And you've heard us say throughout the day so far that we're far behind, but just how far behind are we? I wanted to depict this for you. These are a list of a bunch of nations, not even all of them, that are developing, have developed, or are on the just absolute precipice and further ahead than Canadians with sovereign launch capabilities. And you can see whether it's spaceports or launch vehicles or anything in between. There are a lot of countries out there. I mean, you heard Neil mention we're the only G7 nation without a horse in this race necessarily at the same place. But there are a lot of countries out there that are far ahead of Canada, and there's no reason that we can't be in the same place or, in fact, further ahead. You heard us mention this already in the conference twice already. RadarSat 2, and the reason I bring this up, you already know the facts now. History repeats itself. It's just this is what happens. We're already 200 million taxpayer dollars in the hole with this whole situation that happened. It's going to happen again, and you know it's 100 million for 2 launchers each. Totally support working on not just picking one winner in Canada. It could have built a launch program that could have supported something like this in the last 15 years, and we could have done that. Telesat, another Canadian company, about 14, 15 launches coming up on most likely a SpaceX vehicle. Well, almost $1.5 billion going across our border south for launch. I mean, that's a difficult pill to swallow. That should trouble all of you, especially as taxpayers. We are facing, as Colin mentioned, an Avro Arrow style moment here again. The Avro Arrow is what got me inspired and excited about building in Canada, building in space. I saw the full-scale model of the Arrow back when I was a little kid. I couldn't believe what we had built as Canadians. I wanted to go see it fly, and then only did I realize that we axed that whole program. Pretty heartbreaking moment for me, but I see that same thing happening now again, where we see our student rocketeers who are building amazing technologies, going south, going all over the world, but not building here in Canada. And we can change that, but time is of the essence. The $40 billion space economy is possible, but certainly not without closing the whole loop and closing that value chain. So our goal at NordSpace is to make Canada into a true spacefaring nation, and that means building launch capabilities. So I'm going to tell you a little bit about the different divisions in NordSpace and what we're doing. And we define sovereign launch for Canada very specifically as launching a Canadian payload on a Canadian rocket from a Canadian spaceport. There is no other way about it. If we're honestly building a sovereign capability, it must have these 3 pieces. And I'll talk about why we also decidedly pursued all 3 here at NordSpace. But really, it's because we can't take any risk of us not having any one of those pieces not happening in Canada successfully and not having a true sovereign launch capability. So you have our launch, spaceport, space systems, and the defense side as well, and tell you a little bit about all of them. So our launch program, I'm going to start by sharing a little bit about our main launch vehicle, Tundra, which is our orbital scale launch vehicle. So we have Taiga, which is our suborbital launch vehicle that you see over there. In fact, that's our Mark II of our launch vehicle that we're launching this year. Tundra is our orbital scale launch vehicle, about 500 kilograms to low Earth orbit. Essentially, what we figure is pretty much the minimum that you want to build these days in terms of the capacity that you want to get to low Earth orbit. Anything significantly less than that, we really predict that there's no chance it's going to be competitive, and it's not something that we should be really investing in. And then Titan. This is something that we don't really talk about. It's further away in the future, but it's important for us to let you know that we care about scaling up our technology. A big reason why we chose liquid propulsion, a big reason why we're making some of the design decisions that we are right now, is that it can scale to something that gets us closer to something around 2 tons to low Earth orbit in the 2030s. All built in Canada. So before I get into some of the tech, I'd love for us to maybe play that first video, please. to give you a visualization of what Canada's future in launch will look like. Thank you, that's very kind. So a lot of hard work is going into developing something like this here in Canada, but there's really no reason why we can't do it. So to get into some of the technical specifications here of this vehicle, so this is Tundra. First stage would have 7 of our Hadfield engines. I encourage you, and although these aren't our 35 kilonewton ones, we have our smaller scale ones that are going on our Taiga suborbital launch vehicle over there. Our 3rd generation of that engine is over there on the right-hand side. So please check that out and talk to some of our engineers. Our engines are designed to generate between 275 and 285 ISP specific impulse, and you can get some of the tech details here. We can talk your ear off if you're curious about it. Our 2nd stage is powered by one of our Garneau engines, and it's all it's a really interesting engine cycle. So if you're curious about learning a little bit more, talk to us. 1.5 meter diameter, 22.5 meters in length. I'm really excited to share that we actually have our first ever in-house produced orbital tank test article in the corner over there that our team has been working extremely hard to start developing the actual manufacturing processes in-house that allow us to develop our orbital scale launch vehicles. So at the same time that we're obviously working on our suborbital flight, we're working aggressively on making sure that we're really focused on our main mission, which is getting to orbit and getting there fast. In terms of what we get, so 500 kilograms to LEO, of course, 300 to SSO, and interestingly, 27.5 kilograms to lunar orbit. So maybe we make Andrew Ronan's dream of getting a Canadian rover on the moon from a Canadian rocket possible sooner rather than later. Our Hadfield engines, Chris Hadfield, pretty happy about this. It wasn't necessarily originally, but we're very proud to be honoring everything he's done for Canada. So again, 35 kilonewtons of thrust, and you get all the key data here. A lot of rocket nerds here, which is why we have some of this data up here. But if this is not that interesting, you can scroll past this as I will right now. But this is the thing I really want to mention about this is the first time an integrated piece of engine technology like this is being conceived and developed here commercially in Canada. So this is something that we're taking a tremendous amount of pride in. We design, manufacture, test, and soon fly everything in-house. This is 100% Canadian. Thank you. So our Hadfield engine, the key things I wanted to point out here at the top left, so that's Money, one of our team members who's an expert now in 3D printing. That's our 3D printing facility where we do all of this in-house again. And you produce an engine that looks like that. That was our first hot fire. That was over a year ago now. And I'll show you exactly how far we've come in how short an amount of time. I'll talk a little bit about Spaceport now and get into some of the other tech later. But before I get into that, I'm excited to show our second video today, which is the first time we're publicly showing our beautiful location in Newfoundland, where we're going to be building the spaceport. think we're going to have the most beautiful spaceport in the whole world in Canada. So to give you an idea, though, when we talk about spaceports, especially when we came to Newfoundland for the first time, I think, and we have Deidre and a couple of people here from Newfoundland, we're like, what are these guys talking about? Building a spaceport? Like, well, you know, but really, what we're talking about is building something pretty reasonable, pretty small, pretty similar to, you know, again, what you saw in New Zealand and a lot of other spaceports around the world, where these are a lot closer to regional airports, and the real focus is on getting these small launch vehicles off the ground and not building something massive like a Kennedy Space Center, of course. So Spaceport Canada, and I'll get into some of the details in a second. Amazing location, 46 to 100 degrees in orbital inclinations that we can hit. Launches basically 80% of the year in terms of time. A massive boost to the provincial economy, of course, and global and domestically as well. To get a little bit more specific, so we're building our two sites outside a town called St. Lawrence, a gorgeous and beautiful town. We did an open house there very recently. And so that's Spaceport Canada, right on the southeastern shore, basically of Canada, and certainly of Newfoundland. We have two areas, Slick 1 and Slick 2. They're both designed for certain and individually unique purposes. So Slick 1 is specifically where we're going to be building our orbital launch pads, two of them, one for NordSpace, one for partner vehicles, ideally Canadian, but also looking internationally as well. And Slick 2 is where we're going to have a lot of really interesting ground infrastructure, as well as the capabilities to launch some smaller vehicles for atmospheric research and suborbital style missions. So in terms of the ground infrastructure and the key purposes of the spaceport, obviously we're going to be doing launch. But then there are other applications as well of a site as strategic and as incredible as a spaceport in Canada, and potentially being the first one. We're very excited to see as many of these capabilities as possible in the country, of course. So one is using our radar systems that we're going to be using to track our launch vehicles for something like space domain awareness. This is an incredibly important piece of architecture and infrastructure that Canada needs from a security standpoint in space. And we're going to be doing something exactly on this front, and I'll be sharing that in just a moment. The other part is our communication systems. So of course we're going to be communicating with our rockets, but we're only launching in terms of the time of the year and how much time we're actually using these facilities for like 1% of the year. So we're always trying to find new ways to implement capabilities and infrastructure that has dual use capabilities. So I'm excited for the first time today to announce that we're now partnering with Leo Labs. Leo Labs is an incredible organization with space domain awareness, telemetry, and all kinds of other global networked hardware around the world. And getting them to come to Canada, working with them to build Canada's first space domain awareness capability at our spaceport for sub-meter LEO tracking of everything from debris to payloads to rocket stages and everything in between. So this is going to be huge. We can't wait to see what this means for Canada's defense community, for NordSpace, and for Canada more broadly. So we thank Leo Labs for their partnership. In terms of the timeline, we've been having a very aggressive timeline for the time we've been around as a company. In 2024, it was all about pinning down exactly the site that we wanted to build at. We toured a whole lot of Canada to find Newfoundland to be the perfect spot for a whole variety of reasons. 2025, our goal really is to complete a lot of the key approvals that we require. I'm proud to say that very recently we had both sites, like 1 and 2, rezoned successfully. We also had a temporary environmental assessment approval to perform our launch later this year, and we're working now aggressively on our permanent environmental approvals as well. So lots of great stuff happening all in tandem. Over the next couple of years, we'll be constructing our launch pads themselves and getting our first flight by late 2027, if all goes well. I really wanted to include this image. This is from I guess almost a month ago. We did an amazing town hall open house in St. Lawrence. It's really interesting, right? We're there and we had a great turnout. 100 people were there, the mayor, all kinds of other folks from the province. And we're talking to, Fisher people and people who have no knowledge of rockets, and got them so excited and invested. When I heard that question about, what does this mean? We're talking about the housing crisis and all kinds of other things going on in Canada. Something like this, for the price that it comes with, it gives people, not only does it give people hope that there's something that they can feel a part of, that there's something to be hopeful and excited about when you wake up in the morning. It's not just about problems. But also, this is creating jobs in rural communities. This is allowing us to not send that $1 billion plus south of the border or anywhere else, keeping that at home, creating high-skilled jobs, investing in our local communities and country. Just seeing all that happen is amazing. But over the last year alone, from the spaceport standpoint, the approvals and the detailed plans have really been amazing, and it's taking a village, quite literally, to make all of this happen. We can't take credit for so much of this. So the space system side, I'm going to briefly mention this. And this is a really critical component of what we're doing, because our goal at NordSpace is to become an end-to-end space missions company, very similar to Rocket Lab. I personally take a huge amount of inspiration from Rocket Lab as an organization. I think they're excellent, and an example of what, if they can do it in New Zealand, we certainly can do it in Canada. Example of what we can do as Canadians. But for our space system side, we have a couple of key products that we're developing, some in-house, some in partnership. We have, leaning into our expertise and growing expertise in propulsion, we have our Zephyr thruster systems. Zephyr EP is an electric propulsion system, and Zephyr CH is a chemical propulsion system. We actually have some small prototypes of that specific thruster over there. Kronos is a camera system that we're building for edge AI capabilities, both for EO and RPod style capabilities. And the Athena bus is something that we're building in collaboration with a European partner to support satellite platforms, anything from about a 1U to a 16U. This is something that we were originally trying to do in-house as well, but realized that this is a commoditized and market, and something that we can really benefit from with some partnerships. So our first mission is called Terra Nova. And this is our first satellite, so it'll have basically three key purposes. So one is to test out our Athena bus. The other one is our EP thruster for a very small scale demonstration of firing this in the space environment. And then finally our Kronos AI camera to perform some simple on-orbit demos and get some flight heritage behind some of our hardware. Now, unfortunately, this isn't launching on one of our vehicles just yet, but that's a problem we're going to solve pretty soon, right, guys? And our defense program. So this is something that we're excited now to be more vocal about. I think if you rewind the clock maybe 6 months ago, it's pretty hard to talk about defense and that being something that we're interested in as Canadians, as NordSpace, without sort of getting people squinting at us. And so what we're doing really on the defense side of what we're building is essentially repurposing a lot of the technologies that we're using. We're not building brand new products or anything like that just yet, but reusing our rocket engine technologies and our rocket technologies themselves as a hypersonic test platform, specifically the next version of this Taiga vehicle, to provide new capabilities that Canada really never had from a high altitude, high speed standpoint. So our main defense program is called SHARP, Supersonic and Hypersonic Applications Research Platform, and it has two vehicles. One is Sabre, which is essentially a version of Taiga that's oriented for the defense market, in a lot of ways similar to what Rocket Lab does with HASTE, and Sabre, that's Sabre, and then Arrow, which is our rocket-powered aircraft, which is high Mach numbers, not hypersonic necessarily, high altitude, high velocity test platform as well for runway takeoff and landing style missions that we'll be developing over time. But right now, our focus for that entire defense program is really getting our engine technology, which is the core of those products, to function exactly the way we want them to. So how have things been going? We've been around for May 22nd, I think. We're going to be 3 years old as a company, so we're a pretty young company. Come a long way in a pretty short amount of time. It started February 2023 with Lakshmanan, our chief propulsion engineer. I don't know where, there he is, blowing stuff up on my porch, not too dissimilar from the rocket cannon things that the General Horner or Mr. Kiever made themselves. But that's where we started. And we're like, okay, we're going to need a bigger porch, basically. So less than a year later, basically, we got our facility. We brought in-house manufacturing capabilities. We brought a team on board. We designed literally from napkin sketches, liquid rocket engine, regen-cooled, built a test facility, and successfully fired it. And that was a huge testament to the speed at which we can work at and really make the timelines and the aggressive need for a sovereign launch capability possible. By April 2024, so just a year over that, confirmed our location for Spaceport Canada in Newfoundland and Labrador. January 2025, which is less than a year from our first engine test, we assembled our entire first Taiga V1 vehicle, did a complete integrated vertical test of that vehicle that you see over there. And it was a huge success and confidence boost, letting us know that we can build an entire liquid rocket in Canada at NordSpace in under a year and prepare for launch. So that vehicle over there that you see is the second iteration of what you see here. March 2025, we in-house and printed our 3D printed Hadfield engine Mark III. And we also started now working on our orbital program at the same time now that the engineering behind our V2 Taiga rocket is more or less complete. So you see Ben, one of our expert manufacturing and technician individuals working on our orbital tank, and it's extremely exciting to be working on orbital scale hardware finally in Canada and not having to wait 10 years before we start breaching that. Now, of course, there's a lot of lessons to learn. We're really pushing limits and running through walls, but really it's the only way to learn those lessons early on and implement them as quickly as possible as we start scaling. Finally, we have some really interesting facilities. So we have our basically 3 locations for NordSpace. We have our main office in Markham. That's a 10,000 square foot facility where we do our design and engineering and manufacturing. Then we have our test facility, which is between Toronto and Ottawa. And we're really pleased with that location. And I'll show you a quick video from that place as well. And then finally, we have our launch sites now being developed in Newfoundland. So the Canadian Space Research Range is that specific location. And we're working on this range to be something that not just NordSpace can benefit from. One of our challenges, really, as a company, was that there were no developed facilities for things like testing our engines or launching a vehicle. So we had to do a lot of this initial work to find places, get permission, do all these things to make all of this possible. So that's exactly what we did, and now we're trying to open it up for all kinds of other use cases. We have a robotics team coming by next month to start using that as a place to test their rovers, and so much more. I'd like to just show our third and final video to give you a sense of what a day at a test site is like. There were a lot of moments where I wanted to loosen some of those bolts and just let this thing fly, you know? But I'm kidding. It's so much thanks to our team to actually making this happen. I've worked with a lot of teams in my life, have had the honor to lead a lot of them as well. I've never met one like ours. It's you know, these are the individuals that are going to take Canada to space, and I couldn't be more proud to work with them. So aggressive launch milestones, of course, but our first launch later this year from Spaceport Canada. And then by late 2027 is when we're going to attempt some sort of an orbital flight, and it's going to be big. So funding, growth, how did all this come to happen? What's our story? So everything so far is all private capital for NordSpace. And this is really an important decision and an important pathway that we had to take. So I graduated in 2016 from the University of Toronto's Institute for Aerospace Studies and U of T in general in undergrad in aerospace engineering. And I want to start our rocket company back then. I want to start NordSpace. It's very difficult. I mean, even going to an investor these days or back then and getting 100 grand, and you know that goes so fast when you're building a rocket. So basically got a no from everyone, and it just wasn't the right time. And this is too important. So spent the last 10 years working on other businesses to generate enough personal resources to invest in NordSpace so that we can get this thing off the ground and not have to wait around for the government to come in. We understand they have their pace, but we need to get this thing done. So we started, and we were taking on the initial technical and financial risk. We can't go all the way with this, but with the hope that the right people, you all, can come in and take this thing across the finish line. So that's what we've done, and that's why we've been able to move so fast, because we prioritize speed and innovation and capability development, and fortunately don't have to be chasing around for small amounts of funds to make small amounts of progress. But you know our story reasonably well enough now and how we've progressed. really, at the end of the day, and Alex and several others have already mentioned this, we think for about $100 million in total, we can get an orbital launch capability in Canada. And this is not new. We'll show you a couple of examples. But between our initial phase A, 10 million that we've committed personally to the company, between what we're working on raising right now and extending that investment further as well, because things have been going well, and I have a high degree of confidence that we're going to make this happen. We're working on that phase B so that we can get to our first orbital flight attempt and then go all the way to start commercializing. To give you some concrete examples, again, you heard Rocket Lab and SpaceX. SpaceX did theirs for $80 million in 2006, Rocket Lab for 95. And obviously, these companies are great companies, and they, you can't necessarily just copy and paste and say if they can do it for 100 million, we can do it. But we have a lot of benefits, and we can apply our own advantages here in Canada, whether it's our talent, our very real Canadian discount, modern technology, to actually make all of this happen. We predict over 650 new jobs direct in space by 2035 from this capability, and thousands more downstream from it. And I was going to talk about this, but I think you've heard enough, just how great an example Rocket Lab is now, market cap of over $10 billion. So I want to take the last couple of minutes to mention two things. The CLCD, which is called the Canadian Launch Capability Development Program, and then some quick lessons that we've learned, I've learned especially, from trying to build a rocket company here in Canada. So the Canadian Launch Capability Development Program really is trying to add some more structure to some of the things that you heard today when you're talking about how do we make this happen in Canada. There's one piece which is funding a substantial portion of the sovereign capability for Canada. The other piece is being the first customer. And this isn't something that, Canada has this tendency. We try to choose one winner, or we try to, overly de-risk certain technologies, which are inherently risky, oftentimes. And I'll tell you what I mean in a second. But this program is largely inspired by Vader and the ESA Launcher Challenge. And it's what's allowed a lot of these companies, literally, to get off the ground. Whether it's the Tropics missions from Astra, then went to Rocket Lab, Escapade, and others, Firefly, Blue Origin, Relativity, they all benefit from this program. So when you get a chance, look up Vader. It's a really clean and simple architecture for what we can conceivably do here in Canada. But I really want to highlight that in Canada, we are generally a bit more of a risk-averse nation. This is something that I acknowledge, and that's not going to go away. But we have to be able to classify this risk. And I think one of the most important things for us to build a sovereign launch capability in Canada is not to make rocket science harder than it already has to be. And I think NASA does a great job with this by codifying that and saying a Category 1 high risk, the highest risk is still a common rocket configuration. This is why we've chosen and made the first principles design decisions that we had, because we want to make sure that we're not reinventing chemistry or physics here to try and make something slightly more efficient. We just need to get to orbit. So that's why it's absolutely critical, in my humble opinion, that we choose common rocket configurations to make this happen, and then pair that with Class D missions, so like the Cubics or others, which are highly risk-tolerant missions. Finally, what have we learned so far building NordSpace, building a launch capability? Last word I said, build a capability and not a technology. I think all of us are engineers on our team, and one of the things that we love doing is trying to find new and exciting ways to build the next generation of rocket, engine or something. We really have to try hard to resist that. It's incredibly important. We have to understand what is our goal as Canadians, at least what is our goal as NordSpace, and what do we perceive our goal should be as Canadians. And that's to build an orbital launch capability. And whatever the path of least resistance that still provides a path to scale to do that is, that's what we need to pursue, and that guides a lot of our decisions. That's allowed us to move fast, and that's allowed us to achieve the successes so far and what's hopefully to come. We challenge every requirement and try to delete every part and try to bring things down to their absolute bare minimum, focusing on the mission objectives first and not necessarily all the mission requirements and trying to accomplish those. So being very clear about what is our objective with any given mission, any given project, and making sure that we're aligning ourselves with that and not trying to satisfy requirements that don't make sense. The thing that I've come to really appreciate and love, and there's so many individual people in the audience here that I can call out, is that individual people here in Canada have so much potential and so much power to completely change our future. I used to think when I started NordSpace that, oh, we're going to have to work with the government, the Canadian Space Agency, Transport Canada, D&D, these large nebulous blobs, that we didn't know how we'd interface with. It's all people working there, and they all care about this. And when you find the right people and you become a champion for the right thing, you can do so much as an individual. So I really, really believe in the power of the individual. And I have to give Newfoundland a shout out here. One of the criticisms, or critiques rather, that we often get is, are you doing too much? Are you trying to do too many things at the same time? What I'll tell you for a fact, and we spend a lot of time in the United States, I have not got that question even one time when I go to the US, because, I love Canada, but I think we have a lot of work to do to become an ambitious people. The only place in Canada that I've found where we don't get that question and we are encouraged to pursue greater things is Newfoundland. Complete surprise to me. And that's why we're there, because it is a cultural shift and a mindset that I think all of Canada can benefit from. Their default position, I have found, is to say yes. When you propose an idea or ask a question, it's yes. Everywhere else I found, unfortunately, it's a no. How can we try to find the flaws in things? That's not the approach we can take here, and I'm so proud and excited to be working with Newfoundland. Finally, we optimize for cycle time, design for scale. This is just incredibly important. This is not something that we can take 10 years to develop here in Canada. We have to make this happen fast. Ton of great partners and collaborators, extremely grateful to them. Actually didn't know the slide would get in here, but nothing. That's actually me in the bottom right there, starting with Lego Robotics. Just goes to show how important I think it is. Thanks. To inspire our kids and show them that we can build big things here. We can do big things here. We support over 20 student engineering teams financially across Canada, building rovers, satellites, and rockets, multiple competitions, and just do everything we can to be a part of our community because they are our future. So that's it. The question I always ask, and it's the same one, is it's our choice. Do we want to be participants in space, or do we want to be leaders as Canadians? My decision, I'm sure you can tell, it's to be a leader. I am guessing most of you do as well, but we have to make this happen. We have to be intentional about it. So I thank you for your time today. Thank you for being here at the conference today. It means so much to us. Let's make this happen.